All right, so we started with example 3, and it says that they want us to distribute an algebraic expression from the left. All right, so I'm just gonna go down and rewrite this, and this is what we have. It says rewrite using the distributive property. From the video on yesterday, we learned that distributive means what? What does it mean? What number? Okay, so we learned that we're going to take this outside number and distribute it, meaning use it for the terms that are on the inside, right? But we only do that after we use our order of operations skills also, right? Because we know that order of operations tells us to solve what first? Parentheses. So if you were to take your hand and on your paper you cover up that 4, you are looking to see if you can solve what's on the inside of the parentheses, correct?
Yes.
Can we?
No.
Why not? Use your vocabulary words. Why not? What are they not inside the parentheses?
Like terms.
They are not like terms. Very good. Why are they not like terms?
So the 5 has an X beside
The 5 has an X
it.
and the 7 does not. So since we cannot subtract or add 5x and 7, then we are left to only do what we learned yesterday from the video, which is to distribute 4 to 5x and 4 to negative 7. Okay? Distributive means we're using what operation? We saw it in the video yesterday. We're using multiplication. So mathematically, you are thinking what? 4 what? 4 times 5 what? Very good. 4 times 5x. And what else are you thinking? And 4 times 7. Well, what's directly in front of that 7? A subtraction symbol. So that means I'm going to go put it right there. Because it comes before we say 4 times 7. Right? Okay? Now, what do we do? We're going to multiply where? Okay? Talk louder. The 4 times 5x. What does that give you? 20x. And, okay? 28. Are we in simplest form? Yes? How do we know? What does simplest form look like? Simplest form means, do we have any more like terms or we don't have any more like terms? We don't have any more like terms. So, because 20 has an X and 28 does not, that puts us in simplest form, right? Okay? So then we are done with our distributing. This is in simplest form. Let's go write that so we understand what simplest form has to look like. And this is your final answer. Right there. Okay? Questions? You sure? We're going to have plenty more that we're going to practice. All right? We're going to have plenty more. Once you have that down, go ahead on and move to example 4, which looks almost the same, except for what? What do you notice when you are looking at example 4? Say it louder. Okay, you see more what? What's that word? Okay, I thought I heard just terms, but we do have more terms, okay? And we need to be looking to see if any of them are alike, correct?
Yes.
Okay, so everybody ready? Yes. All right, so I'm going to change my screen, and we are going to number 4. And number 4 says they still want us to distribute, but this time, the number we are distributing is where? It's behind what's in the parentheses. Do you think that's going to change how we look at the problem?
No.
No. It ain't gonna change how we look at it. Probably it looks a little different, but it doesn't change how we look at the math, okay? First things first though, order of operations tells us to check what first? Check the parentheses. Put your hand down and cover up that 6. Look inside your parentheses. Do you have like terms?
Yes.
Where do you think you have like terms at?
The 2 eyes.
The 2 Y's. Okay, well let's talk about those 2 Y's. This Y right here says Y to the what power?
Second.
Second. That Y in the middle says Y to the what? So to the negative means if I wrote Y, how many times did I write it?
Once.
Once. So that's Y to the what?
First power.
Y to the first power. Very good. Now, that's a Y to the second, that's a Y to the first. We need to talk about, are they really like terms? Who plays sports? It don't matter what sport it is. Raise your hand again. You play sports. Okay? Coach has a starting team, right? It don't matter if it's cheer, football, basketball, soccer, whatever. The coach has a starting team, right? But the coach also has people that are sitting where?
On the bench.
On the bench. Okay, first things first. Are y'all still on the same team?
Yeah.
Yes. What makes you a starter versus a person that might be sitting on the bench? Like what? Give me an example. How are you better than somebody else? Basically skill, right? Skill. But depending on what sport it is, your skill, right? So if your skills are a little bit more refined, that means better. That's a nice way of saying better. If your skill level is a little bit more refined than someone else's skill level, that puts you as part of the starting team, right? Now, if you are part of the starting team and you are not part of the starting team, are you all the same? No. You on the same team, yes. But obviously you're not the same because you are a starter. This person is not a starter right now. Now, does that mean that they can't eventually become a starter? They can, if their skill level gets a little bit more refined, right? Just like we can make this Y turn into a Y to the second. Not right now, but a little bit later if we learn to do something else to it. All right? So, is Y to the second and Y to the first like terms?
No.
No, because we just talked about being a starter, which we could say is number 1, and coming off the bench, which we could say is number 2, right? Okay, let's use another example in case people don't get the sports thing. Let's say we go out of town and we want to stay at a hotel. Let's say we're staying at Holiday Inn. We're going to choose something that most people are familiar with. Holiday Inn, right? Are you all aware that hotels have ratings? Tell me what some of those ratings are.
3-star.
3-star? Who, Camille? 5-star. Oh, let's talk about the difference
3-star.
between 3-star and 5-star. What's the difference? Who, Ezekiel?
1-star.
1-star. Let's talk about the difference between these 1-star, 3-star, 5-star. Now, we done skipped all over 2 and 4, but it don't matter. We got 3, 1, and 5. Who's the best?
5.
How do y'all know that? Say what, Camille? It's higher? We also know that in the hotel industry that if something has 5 stars, that means it's the best of the best, right?
Yes.
Okay. You find a Holiday Inn to stay at, and Skynisha find a Holiday Inn to stay at, and Armani finds a Holiday Inn to stay at. Which one are you going to prefer to lay your head down at? 5-star, because it's the best, right? Which one do you probably want to shine away from?
The 1-star.
The 1-star, why?
Because it has the most lowest ratings. It has the lowest ratings.
Lowest ratings, maybe things are not up to par, is why it got its 1-star rating, right? So, even though they both have the same name, Holiday Inn, does that make them the same?
No.
No. So just because we saw Y the fact that this was y squared and y to the first, are they the same? No. So then, in a nutshell, what we just deciphered is that this 3y squared and that y to the first are not like terms. So since we don't have any like terms, what do we now have to do to simplify this problem? We're still talking about distributing. What do we do? Look back at the first example. When I say the first one, I'm talking about example 3. Flip your papers back to 3. We do what?
Multiply.
We are multiplying. What are we multiplying? 6 times everything in parentheses. Well, the 6 is back here, so that means we're going to do that, that, and that. Like a little rainbow. Okay? So, now, this is me. My brain clicks like this. Your brain may not click like this, but it's okay because we don't all look at things the same way. I like to see my single digit number leading the way first. What do we call that single digit number? Starts with a C. It was a vocabulary word we had. Not coefficient, close. Starts with a C. A constant. I like to see my constant leading the way. So since you said 6 times everything, that means that we're going to say 6 times 3y squared. All I'm doing is still reading from the left to the right. Okay? Then what would I write next? Careful. Plus 6 times y to the first. And finish it up with what? Okay, and so what's going to be in between these? A plus or a minus? A minus. Very good. 6 times 8. So mathematically, that's what you're looking like. Okay? I'll give you a minute to catch up. Come on. Did you catch up, sweetheart? Make sure you have that written down, what I have on the board. All right, what are we going to now go do? Do your multiplication. So the first time we are multiplying 6 times 3y squared. We're doing coefficient to coefficient, or constant to coefficient rather. So what is that going to give us? Larry, what you think right here? Let me call on you. What you think right here? What do we have? You got your calculator. 18, that's right. 18 what? What do we bring down?
The y.
Bring down your y squared. That's that term. DeAndre, what you think we have right here, son? 6, very good. Plus 6 what? Plus 6y, very good. Dimitri. What do we have right here? It says negative 6 times 8. Negative 6 times 8. You got your calculator. Use your calculator. Negative 6 times 8. Negative 48. That is correct. So, minus 48. Question is, are we in simplest form?
No.
Yes. Yes. What does simplest form say? Gabriel. Look at your definition for simplest form. How do we know if we are in simplest form? Go look at your definition. Look at that last sentence, I believe. What does it say? Louder.
One is replaced by an equivalent expression having no like terms or parentheses.
No like terms or parentheses. Do I have any like terms?
No.
No, because y to the second and y to the first are not alike. So we are in simplest form. All right, any questions? Any questions? Are you sure? give y'all another one. I'm gonna write it right here on this paper.
Which one on the back, example 5?
We are gonna do example 5, but this one is gonna stay with 4, okay? We're gonna stay with 4. What if I gave you all a problem like this? 2 times, let's go 3a plus 6 minus 2a. Think about what I've been asking you, the order in which you should solve your problems in. Okay? Okay. 2 things in math. You always want to exercise your order of operation skills, and you always want to look for if there are any like terms. Can I do some condensing?
Yes.
Right? That's what you always want to do, because you want to try to make the problem smaller before you start doing a whole bunch of math. So, order of operations tells y'all to look where? In your where? In your parentheses. So when you look inside your parentheses, if we were to cover up that 2, we realize that inside the parentheses, what do you have? Like terms. Call them out. What are they?
3a.
We have 3a plus 2a. Boom. Oh, careful. I said 3a plus 2a. Was I right? No. What did I mess up on?
The 2a is negative.
The 2a is negative, so what should I have said? And close that door for me, please. I should have said 3a subtract 2a. So 3a minus 2a, well, what does that leave us with? Count your money.
1a.
Very good. It leaves you with 1a. Now, I'm going to tell y'all this, in the world of math 1, they do not write that 1 in front of an a, or b, or c, or x, or y. If it's just one of them, they just write the letter. So that means you all have got to get used to understanding that no number in front of a variable means what value does it hold. It holds a value of 1. Very good. All right. What else do we have happening in this problem? Plus 6. And 2 is on the outside, right? Okay, very good. So the first thing you did was look in your parentheses. You realized you had like terms. You found them. You did the appropriate math, which was to subtract them. Now you're at a point where I still have parentheses, but are there any more like terms?
No.
No. So what does that force us to do now? Multiply. What property are we exercising? Distributive property. What number are we distributing? 2. To A, 1a, and 6, right? Now, some of you might need to do this. That means 2 times 1a plus 2 times 6. If that's you and that's what you need to do, then you write it down. You don't, because others of you may be able to just draw your arrows like I've done and look at it and say, oh, I know that's 2 times 1, which is what? 2 what? And I know that 2 and 6, 2 times 6 is what?
12.
Some of you may be able to look at it, just looking at it up there, and know what it is. While others of you may have to write it out and then go back and say, oh, 2 times 1a is 2a, and then again, 2 times 6 is 12. You need to do what works for you. Everybody don't need the same thing. Typically, I try to show you all like various ways. You gravitate to the one that you understand the best. Okay? What questions do you all have? Are there any questions? No questions? You sure? All right. Let's go ahead on over to 5, because 5 is now going to start to put it all together, and we're going to have to do everything together. Okay? Or actually not 5, 6 is the one that does that. I'm sorry. It's 6 that does that. That's going to put it all together. 5. read what we have for 5A because mine didn't populate.
14
14A
plus
plus
18A.
The board wanna be temperamental with me. Hold on. Okay. All right, there we go. All right, for A, we have 14A plus what?
18A.
Plus 18A, and then for B, it said what?
14A
Plus 9B. Subtract.
Okay. All right, here is just straight up, we're doing what? Simplifying, which means we're looking for what if we're simplifying? We're looking for like terms. Very good. If we're simplifying, we're looking for like terms. Cut and dry. Look here. Do we have like terms in A? We got 14A plus 18A. Do we have like terms? Yes, we do. So what are we going to go down and do? Add them. All right, class. 14A plus 18A.
32A.
32A. Is there anything else that we can do? No. So are we in simplest form?
Yeah.
Absolutely. All right, let's go look at B. What do we notice?
Like terms.
We have like terms, okay? Where? 9B and negative 3B?
Yeah.
Okay. What happens here?
Subtraction.
We subtract them, and what do we get?
16.
We're gonna get 6B. Well, what happens to 14B squared? So do we let it fly in the wind, or do we still gotta like pull it with our 6B? We gotta pull it with the 6B, so basically we just bring it down, and that's what we have. Boom. Are we done?
Yes.
Yes, we are. Any questions? No questions? This last one that we're gonna do is gonna tie everything together. It's gonna pull it all together for us. So this is gonna be like your exit ticket. You're gonna have to be able to, one, write me an algebraic expression. Have we practiced that last week? Yes. Two, do you know how to combine like terms? And three, do you know how to execute your distributive property? We're getting ready to do all three of those in this last problem. So this is going to be like the feel of your exit ticket. Are we ready to go? Yes? Okay, here we go. It says, write and simplify expressions. Complete the table to write an algebraic expression for 3 times the sum of 2x and 3y. Decrease by twice the difference of 4x and y. Part B, simplify your expression, and it says indicate the properties used. We're not going to indicate the properties used, but we are going to simplify the expression. Go find your chart that looks like this. Okay? Now, some reason or another, when I start trying to transfer these PowerPoints from the reveal math, sometimes my charts don't answer it, Randy, please. Sometimes my charts don't come over. So right here, I think it says this in yours. 3 times the sum of 2x and 3y. Is that what it says?
Yes.
Okay, and then this one over here says twice the difference. Twice the difference of 4x and y. Okay. We got the first write out algebraic expression. The first part, 3 times the sum of 2x and y. What if I told you I was 3 times the age of your brother and sister, how would you know me? If I said I was 3 times the age of your brother and sister, if you had a brother and sister, or your 2 sisters, or your 2 brothers. So if I said that I was 3 times the age of your brother and sister, what do you have to do to find me first? You got to find your sister and brother age, right? So if we go back to this problem, because I took what I said from this, what represents the sister and brother in this? Very good. How are we going to show 2x and 3y mathematically? What mathematical operation? I'm 3 times, what's that word? Sum. So what has to happen with your brother and sister? Addition. So 2x plus 3y. And then if I'm 3 times that, what do you do with that? Okay? Parentheses, and you said put the 3 for multiplication, correct? That's your first algebraic expression. All right? Decrease by, well, what does that mean? Subtraction. Very good. So right here, we need a subtraction symbol. All right, boom. Twice the difference of 4x and y. That's almost the same as what it said over there, right? I am twice the difference of your mom and dad's age. How do you find me? What do you need to do first? Find your age of mom and dad. Well, what represents mom and dad over here? 4x and y. Now, what are we doing between 4x and y? Subtraction. But I'm twice the difference of their age. So once you subtract their 2 ages, then you got to go back and do what? Multiply. By what number?
2.
How do you know it's 2? Because it says twice. So far what you've just done is reviewed how do you write your algebraic expressions. We did that last week. Now what is it that we're getting ready to do? Solve them, simplify them. I heard distributive property. Let's go here. Can we add 2x and 3y? No. So what do? Distributive property, which is multiplication. 3 times 2x and 3 times 3y, correct? Okay, tell me what we have. Talk to me.
9y.
Very good. 6x plus 9y. Very good. I drop down this decrease by, don't I?
Yes.
And then over there to the far right, what do I need to do? Multiply or distribute again. What are we distributing? Talk up, y'all. 2 what? 2 times the 4x and 2 times the negative y, right? Okay. Tell me about 2 times the 4x. That's 8x. And tell me about 2 times the negative y. Negative 2y. That's an understood 1. So that's like saying 2 times negative 1, isn't it? Okay? So now we've done our distributing. The final step is to do its simplifying, right? Okay, I'm going to just squeeze this together so y'all don't look like y'all looking spaced out. And I'm going to put it up here. We have 6x plus 9y minus 8x minus 2y. What do we look for now to finish simplifying? Like terms. Where are your like terms, ladies and gentlemen? You know what? Hold on. Every single class I've had today, I asked where are my like terms, and y'all have jumped to the y's first. Is that the only set of like terms?
No.
What else is like terms?
6x and 8x.
6x and 8x. I can't understand why everybody jumped to the y's first, but it's okay. let's do the y's. 9y minus 2y. What you have? 7y, what kind of 7? Positive or negative?
Negative.
9 minus 2?
Positive.
Positive, very good. So plus 7y, and the x's lead because x is in front. 6x minus 8x. 6 minus 8. $6 in your pocket, and you owe me what?
Negative 2.
Okay, because if it's $6 in your pocket and you owe me 8, that means you are 2 short, right? So that's negative 2 what? X. And boom. Do we have any more like terms?
No.
No. This is our answer in simplest form, and that tied everything together. It went back and tied in your algebraic expressions that we worked on last week. How do we write an algebraic expression? It tied in looking for your like terms and having to distribute. Are there any questions?
No.
Are you sure? Positive. All right, you're going to have 3 practice problems for homework.